the biggest explosions of radio energy in the entire universe generate more energy than 1 billion suns. In this video, we bring you an urgent and jaw-dropping announcement from NASA's top official. The entire star, a white dwarf, goes unstable, collapses, and becomes a supernova. The chief of NASA has finally broken the silence on a cosmic event that could have profound effects on Earth. Like any star, it will run out of fuel in its core, causing it to change. It will start bloating, becoming so large that it will engulf the orbits of Mercury and Venus, coming very close to Earth. According to recent revelations, the red supergiant star Betelgeuse is set to explode in a spectacular supernova in 2024, and the impact could be felt right here on our planet. It's very unstable and about to explode. To give an estimate of the timing, it could be tomorrow. Imagine looking at the horizon at sunrise and seeing half the sky illuminated. That would be terrifying. Betelgeuse, a fascinating star in our night sky, shines with an eye-catching orange-red glow that draws the interest of stargazers. What makes this star unique is its interesting variability over time. Betelgeuse puts on a cosmic show where its brightness changes. At times, it shines intensely, matching the brilliance of the brightest stars, radiating at a remarkable magnitude close to zero. However, the sky is filled with stars, each with its unique brightness. Consider Rigel and Aldebaran, two stars with contrasting luminosity. At its peak, Aldebaran can rival Rigel's brightness, but when it dims, it resembles Aldebaran's modest glow. This celestial display is influenced by the star's size, temperature, and distance from us. In a recent span of just over 5 years, Betelgeuse staged a captivating performance, presenting astronomers and space enthusiasts with unexpected challenges and complexities. Adding to its allure, Betelgeuse is known by various names, including Bellatrix, Betelgeuse, and Belgia. It's fascinating how this celestial body can be referred to by multiple names and spellings. The origin of its name can be traced back to the Arabic language, where the suffix "Jus" aptly suits its stellar characteristics. According to scholars, this enormous star is one of the most fascinating objects we can see in the night sky. It's a huge red supergiant star that's about 642.5 light-years away from us, drawing the interest of astronomers and people who have loved looking at stars for many years. Even though it's so far away, Betelgeuse still stands out like a garden in space. Thanks to the Hipparcos satellite, a super-advanced space tool, we've learned something new. Scientists have used its data to figure out that Betelgeuse is about 430 light-years away. This shows how tricky it can be to measure things in space accurately. Apart from its distance, Betelgeuse's brightness changes over time. Astronomers have seen it go from being bright with a magnitude of 0.0 to still quite bright with a magnitude of 1.6. This changing brightness has puzzled astronomers for a long time, leading to lots of study and thinking. It helps us learn more about how big stars like Betelgeuse live and die. Underneath its shining surface, Betelgeuse acts like a laboratory where we study how stars work. But maybe the most exciting thing about Betelgeuse is what's going to happen to it. It's getting ready to explode in a supernova event. This explosion will be incredibly bright, like billions of suns shining at once, and it will leave behind something really interesting, like a neutron star or a black hole. This explosion will be so huge that we might even see it during the day for a while. It's going to be an amazing sight that will leave people in awe for generations to come. Betelgeuse emerges as one of the most captivating figures in the night sky. This mysterious star, known scientifically as Alpha Orionis, shines as the second brightest gem in Orion's belt, with only Rigel surpassing its luminosity. However, Betelgeuse possesses an unpredictable nature capable of surpassing Rigel's brightness, challenging our expectations of stellar stability. The name Alpha Orionis originated from Johann Bayer's Uranometria, a celestial map published in 1603. Since then, this cosmic identity has been firmly established in our understanding of the starry sky, with Betelgeuse assuming a central role as the guiding light of Orion. Astronomically speaking, Betelgeuse stands apart as a solitary performer in the cosmic theatre, not belonging to any larger stellar cluster. It resides far from the bustling regions where new stars are born, existing as a lone sentinel in the vast cosmic void. Adding to its allure is the fact that Betelgeuse is a runaway star, moving through space independently without gravitational ties to a stellar family. What makes it particularly fascinating is its immense size. To illustrate, Betelgeuse's radius expands to a staggering 764 times that of our Sun, while its mass dwarfs the Sun's, measuring approximately 16.5 times the solar mass. This classifies it as a red giant, a magnificent inflated version of its previous self. Betelgeuse stands out for its remarkable brightness, shining with the radiance of 126,000 suns, a brilliance that remains striking despite being so far away from Earth. Despite its vast distance, Betelgeuse's brightness defies expectations, thanks to its enormous size. This red giant's immense dimensions allow it to maintain its luminosity even at such cosmic distances. However, Betelgeuse's appeal goes beyond its size and brightness. It intrigues scientists with its unique temperature dynamics. Unlike our Sun, which burns at about 5,778 Kelvin, Betelgeuse is cooler, with a surface temperature of around 3,600 Kelvin. This temperature contrast is fascinating and showcases the diverse nature of stars. Despite its colossal size, Betelgeuse bucks the trend of scorching heat associated with such massive stars. At approximately 10 million years old, Betelgeuse is relatively young in astronomical terms compared to our Suns for 0.6 billion years. Yet, it has already matured fully as a star, hinting at its potential for cosmic drama in the form of a supernova. Supernovae mark the dramatic end of massive stars, and Betelgeuse is no exception. When it reaches the end of its stellar life, it will unleash a cataclysmic explosion, emitting immense energy and radiation. This spectacular event, expected within the next few 100,000 years, or possibly sooner, underscores the dynamic and ever-changing nature of the cosmos. Betelgeuse's story is a testament to the complexity and beauty of the universe's celestial bodies, showcasing how even stars with immense size can surprise us with their unique characteristics and eventual cosmic fireworks. Imagine looking up at the night sky and seeing a massive explosion in space as bright as a whole galaxy. This is what a Betelgeuse supernova would be like. It would send out a huge amount of energy in different forms, like light, X-rays, and gamma rays, flooding our solar system. Our protective shield, called the magnetosphere, would struggle to handle this sudden burst. The night would turn into day because of Betelgeuse's intense brightness, even brighter than the Moon. The scary part is that it could bathe Earth in harmful radiation. Now think about if another nearby star, like Alpha Centauri, also exploded spectacularly. We couldn't just ignore it. The effects would be serious and widespread. First, the intense light would confuse nocturnal animals. Plants might have trouble adjusting to so much light, and humans would face big challenges too. Betelgeuse's supernova would be an amazing sight, but it would force us to change how we live in major ways. The radiation from this space event would be dangerous for life on Earth. It could damage the ozone layer, leading to more skin cancer and health problems. Our satellites and communication systems, which we rely on a lot, could get disrupted or damaged. And it's not just Earth that would feel the impact. The shock waves and radiation would affect other planets and objects in our solar system. Scientists around the world would be keen to study what happens after a nearby supernova, as it would give them a chance to learn a lot about how these events shape our cosmic neighborhood, both in the short term and over longer periods. Throughout history, the night sky has always been consistent, with no extraordinary events like a supernova until 1987. That year, an incredible sight appeared in the Large Magellanic Cloud, a distant galaxy about 169,000 light-years away. This event fascinated astronomers and anyone who gazes at the stars, showing us a glimpse of how vast our galaxy truly is. Supernovae are significant because they leave behind remnants that help us understand more about the universe. One specific remnant, called G29.2 plus 0.1.8, is particularly interesting. It comes from a type of supernova that has a lot of oxygen, making it unique in our galaxy. What makes this supernova remnant even more special is its distance from Earth. It's far enough away that it doesn't pose any immediate danger to our planet. If it were closer, within about 100 light-years, it could have catastrophic effects on Earth and nearby celestial bodies. For example, Alpha Centauri, our closest neighboring star system, would be at risk if a supernova happened nearby. However, beloved stars like Betelgeuse in the Orion constellation would be safe from its harmful effects. Studying these cosmic phenomena is not just about satisfying curiosity, it also teaches us humility in the face of the vastness and potential dangers of the universe. Although the G2 92.0 plus 1.8 supernova remnant in the Large Magellanic Cloud is a captivating subject for research, the idea of a supernova occurring closer to us brings both excitement and a reminder of our place in the cosmos. The last recorded supernova within our Milky Way galaxy occurred in 1604, highlighting the rare occurrence of such spectacular events. This long period without a supernova has left us eager for the brilliance and knowledge these cosmic displays can offer. Understanding the life cycle of stars, from their birth to transformation and eventual end, relies heavily on these magnificent explosions. The study of supernovae, especially their remnants like G2 92.0 plus 1.8, gives us a glimpse into the universe's fundamental processes. These remnants act as windows into the cosmic factories where heavy elements, crucial for life as we know it, like oxygen and iron, are forged. These elements are then spread across space, contributing to the creation of new stars, planets, and ultimately, the emergence of life itself. Being the nearest red supergiant star to Earth, Betelgeuse has captivated people's imaginations with its potential to one day explode in a supernova. This curiosity was amplified when, in late 2019, Betelgeuse experienced a notable dimming, creating a celestial spectacle that captured global attention. This event sparked excitement and anticipation within the astronomical community as many eagerly awaited the possibility of witnessing the massive star's grand explosion. However, the unfolding cosmic drama took an unexpected twist. Betelgeuse, often called the hunter's right shoulder due to its position in the Orion constellation, is renowned for its vibrant crimson color. It is most prominently visible during the early months of the year in the evening sky, making it a cherished target for both amateur stargazers and professional astronomers alike. The sudden dimming of Betelgeuse towards the end of 2019 sparked excitement and curiosity among astronomers. Some speculated that this dimming could herald the long-awaited supernova explosion of Betelgeuse. This unusual dimming event prompted extensive investigations by astronomers, who meticulously analyzed data from NASA's Hubble Space Telescope as well as observations from various ground-based and space-based observatories. The discoveries made during these investigations were nothing short of remarkable. Betelgeuse did not undergo a supernova event, but it did release a significant part of its visible surface in what astronomers called a massive surface mass ejection, SME. To put it simply, Betelgeuse expelled a piece of itself into space, a phenomenon never seen before in a star of its size. This discovery prompted scientists to rethink how they view massive stars and the processes that occur within them. Previously, it was thought that stars like Betelgeuse would explode dramatically at the end of their life cycle. However, Betelgeuse's SME showed that these large stars might display more complex behavior before their final stages. The recent changes in Betelgeuse's brightness were not signs of an imminent supernova, but rather a peek into the intricate and dynamic nature of these massive stars. It appears that Betelgeuse is entering a less active phase, although it has regained some of its previous brightness. Betelgeuse recently caught the attention of astronomers due to a puzzling dimming. What caused this darkening wasn't just any usual event, it was a massive natural occurrence called a coronal mass ejection, CME. Understanding what a CME is helps us appreciate the awe of this cosmic phenomenon. The Sun, our radiant celestial neighbor, often triggers these eruptions. During a CME, part of the Sun's thin outer atmosphere, known as the corona, is ejected into space, creating a stunning yet dangerous display of nature's power. While CMEs are common in our solar system, Betelgeuse, a prominent star in the Orion constellation, took it to a whole new level. It exhibited behavior that puzzled even experienced stargazers. Unlike typical CMEs that release small amounts of material, Betelgeuse unleashed an enormous amount, ejecting a staggering 400 billion times more mass than an average solar CME. It was like a cosmic storm engulfing the star, leaving astronomers amazed. The enormity of this event is truly staggering. Picture 400 billion suns exploding at once, launching an immense cloud of hot gas into space. This incredible display of cosmic power obscured Betelgeuse's light, creating uncertainty among astronomers. While Betelgeuse's dimming was clear, its exact cause remained unclear. Initially, some thought it might be nearing the end of its life, heading for a spectacular supernova. However, new evidence suggests that the massive CME was likely behind this mysterious dimming. Imagine the gigantic cloud of hot gas released by Betelgeuse during the CME. This massive eruption briefly masked part of the star's bright light, similar to a cosmic eclipse. This unusual event puzzled astronomers because it was unlike anything seen before. The dimming of Betelgeuse was a remarkable event in astronomy, yet pinpointing its exact distance from Earth has been quite challenging. Astronomers have carefully studied this massive star and used different techniques to measure how far away it is. Some approximations suggest that Betelgeuse is around 724 light-years away from us, which is relatively close in space terms. However, the quest to understand the strange dimming caused by its unusual CME is still ongoing. Scientists are deeply committed to unraveling the mysteries surrounding Betelgeuse. They are using advanced tools like powerful telescopes and sophisticated spectrographs to examine this celestial phenomenon. Their dedication to uncovering the secrets of the universe drives them to explore this cosmic puzzle further. Understanding the distances of red supergiant stars like Betelgeuse is a captivating and complex puzzle in astronomy. Despite being incredibly far from Earth, Betelgeuse shines brightly in our night sky, which is truly remarkable. It's not just any star, it's among the most luminous stars visible to us. In fact, it shines with such brilliance that it outshines our Sun by an astonishing factor of 100,000. This tremendous brightness is both impressive and challenging. Betelgeuse's exceptional luminosity comes with a cost. The massive energy it emits rapidly depletes its fuel reserves, creating a race against time. The more brilliantly it shines, the sooner it will exhaust its energy and reach the end of its life cycle. This balance between radiance and depletion adds a layer of intrigue to the study of Betelgeuse and other stars like it. Betelgeuse is burning its nuclear fuel very quickly, which means it's moving rapidly towards a big and destructive end. Eventually, this amazing star will run out of nuclear fuel. When that happens, when Betelgeuse runs out of nuclear fuel, it won't have enough energy to push back against its gravity. This massive star will then collapse in on itself. The result of this process is a huge and amazing event, called a supernova. Betelgeuse, in its last moments, will explode dazzlingly and breathtakingly. The explosion will be so bright that it might be as visible as the full moon in our night sky, maybe even during the day. This will turn the sky into a stunning show of fireworks. This incredibly bright star will end spectacularly, leaving a lasting impact on the universe. As the year 2020 began, Betelgeuse suddenly became much dimmer, surprising everyone who observed the night sky. Its usual brilliance, which was at a luminosity of 0.5, decreased significantly to 1.7. However, Betelgeuse didn't stay dim for long. It started to regain its luminous appearance, resembling a majestic phoenix rising from obscurity. This event sparked curiosity and amazement among scientists and space enthusiasts worldwide. People wondered what caused Betelgeuse's sudden dimming and subsequent resurgence. Some speculated that it might be a sign of an impending eruption, given the unusual nature of such a phenomenon. To uncover the mystery behind Betelgeuse's behavior, a skilled astronomer named Miguel Montazes led a team that utilized the advanced capabilities of the Very Large Telescope. Their goal was to study Betelgeuse in detail, hoping to understand the reasons behind its fluctuating brightness and unravel the cosmic puzzle it presented. Their investigation uncovered not just one, but two explanations for Betelgeuse's behavior. Beneath the star's fiery surface, massive convective cells churned, creating a fascinating pattern of hot and cold regions on its surface. This intricate mosaic was the first piece of the cosmic puzzle they were trying to solve. The second discovery was equally intriguing. Betelgeuse had produced a mysterious cloud of dust drifting in space and obscuring its starlight from our view. This cosmic veil played a significant role in Betelgeuse's dimming, adding another layer of complexity to the celestial drama unfolding. While the exact timing of Betelgeuse's predicted eruption remains a mystery, the anticipation of such an event is thrilling. Scientists believe that when Betelgeuse eventually explodes as a supernova, it will be a spectacular cosmic event. It may even shine brightly enough to be visible during the day on Earth. Betelgeuse holds a special place as a neighboring star relatively close to our planet in the vastness of the universe. No need to worry, as the spectacular display of a supernova will unfold far away from our reach. Betelgeuse, positioned more than 500 light-years distant, will showcase its celestial fireworks safely beyond our celestial boundaries. For a supernova to affect Earth, it would have to approach much closer, within about 50 light-years. This cosmic performance, although mesmerizing, poses no imminent threat or cataclysmic consequences to our planet. Adding to this cosmic symphony, in 2021, another colossal star, VY Canis Majoris, a red hypergiant, experienced similar captivating dimming events like Betelgeuse. NASA's Hubble Space Telescope captured this grand celestial tale, highlighting the vastness and majesty of this immense star. The story of VY Canis Majoris echoed Betelgeuse's cosmic verses, showcasing the ever-changing and enigmatic beauty of the universe that continues to unfold before our curious eyes. Betelgeuse's cosmic performance is wrapped in uncertainty, making it a celestial puzzle waiting to be solved. We can't predict when it will reach its grand finale. It could dazzle us with its cosmic show tomorrow or wait millions of years to do so. Betelgeuse is on the brink of a remarkable transformation, with the potential to explode as a supernova over the next 100,000 years. Once a prominent member of the top 21 brightest stars, shining at a remarkable magnitude of 0.69 and ranking 11th among stellar luminaries, recent evaluations have shown a significant drop in its brightness to approximately 1.7, moving it down from the stellar A-list. This intriguing dimming has sparked intense discussions and theories in the media. Some propose that it heralds Betelgeuse's imminent supernova explosion. However, many professional astronomers and astrophysicists diverge from this idea. They believe that Betelgeuse will eventually regain its stellar radiance. The current dimming is likely due to other factors like gas and dust eruptions or fluctuations in the star's surface brightness. Betelgeuse holds a fascinating history steeped in mythology and cultural references. In the vast expanse of cosmic naming, the Arabic language plays a significant role, highlighting the influence of Arabic astronomers and astrologers during Europe's Dark Ages. They named many prominent stars, showcasing their expertise and knowledge. The name Betelgeuse itself comes from Arabic, meaning the armpit of the giant. However, there's a captivating twist to this interpretation. Some experts suggest that Betelgeuse could also represent a hand or shoulder, deviating from the traditional association with Orion, the famed hunter in mythology. This divergence adds layers of intrigue to the star's significance in celestial history. Betelgeuse is the name given to the star situated on the right shoulder of Orion in astronomy. The exact meaning behind this name remains somewhat mysterious. It's not surprising that most descriptions of Betelgeuse involve some reference to anatomy, considering Orion is often seen as a giant warrior or hunter in ancient stories, often depicted with human or animal-like features. However, the story doesn't stop there. In various cultures, Betelgeuse takes on different roles. In parts of Brazil, it's portrayed as the front leg of a turtle or the hind leg of a caiman, a type of crocodile. Meanwhile, in Japan, ancient beliefs connect Betelgeuse to a ceremonial drum, symbolizing a severed limb of a human figure, often associated with Orion. Throughout the Americas, from the Lakota tribe in North America to the Taulipan people in Brazil, Betelgeuse plays different roles. In various cultural tales, Betelgeuse is seen as a leader with a missing arm, a brave figure whose wife cut off his leg, or a bright symbol tied to stories of lost limbs. These stories and symbols around Betelgeuse highlight a rich imagination among different peoples, where this one star, seen differently by various cultures, becomes many things, each carrying history and myth. This diversity shows how deeply the night sky has influenced human thought over time, creating tales and connections that still intrigue us today. In ancient times, Betelgeuse was referred to as the Moist One in Sanskrit, reflecting its connection to the Ardra lunar house in Hindu astrology. This link is significant because, in Hindu beliefs, celestial bodies like stars can affect people's lives. Betelgeuse is also part of the Rigvedic storm deity Rudra's mythology. The stormy nature of Orion, where Betelgeuse is located, was cleverly associated with Rudra in the 19th century by Richard Hindley Allen, an avid astronomy enthusiast. This connection suggests a fascinating relationship between stars and ancient beliefs, showing how celestial bodies were perceived as influencing human destinies. In Macedonian culture, Orion symbolized agriculture and rural life, reflecting the importance of farming and village traditions. Betelgeuse, a part of Orion, held special significance as it represented the plowman, known as Auric. The stars rising around 3 a.m. during late summer and early fall marked the time for villagers to begin plowing their fields, tying Betelgeuse to the agricultural cycle. Similarly, the Inuit people of the Arctic viewed Betelgeuse and Bellatrix rising in late February and early March as a sign of spring's arrival and lengthening days. These stars, rising high in the southern sky after sunset, were referred to as those two placed far apart. Their position served as a celestial clock, indicating the changing seasons and guiding activities like planting and harvesting in harmony with nature's rhythms. Different cultures have connected Orion and Scorpius, along with their prominent red variable stars Betelgeuse and Antares, as symbols of opposing forces. This duality mirrors concepts like Shen and Shong in Chinese culture, representing eternal struggles. The setting of Orion and the rise of Scorpius symbolize Orion's defeat by the Scorpion, creating a celestial tale of perpetual conflict. For the Batak people of Sumatra, a significant celestial event marked the beginning of their new year. The first new moon after Orion's belt disappeared below the horizon while Betelgeuse still resembled a rooster's tail. This event held deep cultural meaning, signifying renewal and new beginnings. Betelgeuse and Antares, positioned at opposite ends of the sky, were seen as guardians of the cosmos, framing the celestial sphere. Their constellations were often interpreted as scorpions, with special scorpion days dedicated to honoring their visibility. In these ancient stories, Betelgeuse emerges as a central figure, playing a role akin to a cosmic protagonist in humanity's ongoing exploration and understanding of the universe. Its journey across cultures and time underscores the profound impact that celestial bodies have had on shaping our beliefs, traditions, and rituals. Our sun receives a lot of attention in terms of stars, as life on Earth practically revolves around it. From our vantage point, the sun dwarfs other stars in the sky. However, the sun appears smaller when viewed from the remote reaches of our galaxy, though its size is rather typical. First, let's talk about stars. There are many distinct kinds of stars, some are bigger than others. However, before moving on, it's important to realize that stars don't have neat, defined boundaries. Unlike rocky planets or moons with solid surfaces, stars are made of superheated masses of gas that gradually thin out into nothingness, leaving them with somewhat dispersed surfaces. A star's photosphere, the point at which the star turns transparent, i.e., where photons can escape the star, is what astronomers use in place of a surface. So, when we refer to a star's surface, we actually mean its photosphere. The second crucial point to keep in mind is that we have never directly measured a star. No one has gone up to a star with a ruler to measure distances. Instead, we have estimates, mostly accurate estimates, but estimates nonetheless. These estimates can be more or less precise, depending on factors like the distance or structures around stars or between them and Earth, i.e., we know a star is between X and Y miles or kilometers wide. You might recall learning in school science class that the sun is a star rather than a planet. The sun can appear enormous when you look up during the day. This might lead you to conclude that it's the biggest star in the galaxy. However, Uy Scuti is hundreds of times bigger than the sun. The sun appears larger partly because of its proximity to Earth. Although the sun is a huge star, it is not by any means the largest star in the cosmos. What is the largest star that has been discovered in the universe? The answer depends on whether you're referring to a star's mass or total volume, i.e., how much space it occupies. According to Phil Massey, an astronomer at the Lowell Observatory in Flagstaff, Arizona, when it comes to size, the heaviest stars are frequently unimpressive, while the most massive stars are frequently faint. This is because older stars tend to expand and lose mass. Massey compares this to humans, noting that the tallest people might not weigh the most. If you're discussing mass, the star R136A1 holds the record. It is located in the Large Magellanic Cloud, a tiny galaxy that revolves around the Milky Way, around 160,000 light-years away from Earth. Imagine a cherry next to a gigantic yoga ball, R136A1 is more than 200 times more massive than our Sun and 30 to 40 times larger in diameter. This star is also quite young, having lived for only 1 million years, compared to our Sun's for 0.5 billion years, and hasn't undergone any significant cooling or expansion. There are several contenders if the definition of the largest star in the universe is the one with the largest diameter, and Ui Scuti is at the top of that list. Astronomers at the Bonn Observatory in Germany first noticed it in 1860 and designated it BDR 125055. After more observations revealed that BDR 125055 changes in brightness. Over the course of 740 days, it was determined that the star Ui Scuti is a variable star. Its diameter is approximately 1,700 times that of the Sun.